Hello everyone. In this video we're going to be comparing two numbers given in exponential form. So the question is, we have 5 to the power 51 and 2 to the power 120, and we got to figure out which number is greater. Great. So what are we going to do? Obviously these are very large numbers. We're not going to evaluate them. If you use a calculator, that doesn't count. So we're going to be using some manipulations to be able to compare these numbers. Now, when you see a problem like this, probably some of you are thinking about the following. How about I take 5 to the power 50 and compare it to 2 to the power 120? Why? Because their exponents have a common factor, which is 10. So if I'm able to compare 5 to the 5th and 2 to the power 12, then I should be able to raise both of these numbers to the 10th power because the order is not going to change. Obviously, that's that simple, right? When they give you something like this, that's definitely a way to go. So let's go ahead and take a look at this and see what happens. Well, 5 to the 5th power is basically 3,125, and 2 to the power 12 is supposed to be 4,096. Now, as you can see here, 3,125 is less than 4,096. Obviously, when you raise them to the 10th power, the inequality will be preserved, right? They're going to be the same order. But does this help at all? Well, it means that 5 to the power 50 is going to be less than that. So my original number, we can safely say that, okay, this number must be less than that. But I'm not supposed to compare 5 to the power 50 with 2 to the power 120. I'm supposed to compare 5 to the power 51. So the question is, this inequality is true, but what happens if I multiply the left-hand side by 5? Is it still going to be smaller than the right-hand side, or is it going to exceed the right-hand side? Does that make sense? So that's the thing that you need to think about. And you can obviously, at this point, you can think about the 5th root of 10, because if you take the 10th root of both sides, you're basically be getting something like this, right? 5 to the 5th and 2 to the 12th. And if you multiply this number by the 10th root of 5, which is going to be 1 point something, right? When you multiply it by 3,125, is it still gonna be less than this number? That is the question you need to answer, right? And that question is not very easy to answer. Obviously, there are different ways to go about this problem, but the method that I'm going to show you is going to be a little different than this idea. Okay, here's what we're going to be looking at. So in order to compare powers of 5 and powers of 2, what are you looking at? Let's go ahead and expand some powers of 5 and 2, and let's see what they look like. So powers of 5 and powers of 2. So this is what I'd like to do. Just list some powers of 5. So first power, second power, third power, fourth power, and then fifth power, right? Okay, great. And you can just continue this list, make more and more. But since the numbers are going to be real apart, you don't really need to go that far. When you look at powers of 2, you notice that they're fairly easy to find. 2, 4, 8, 16, 32, 64. And notice that they don't grow that fast compared to powers of 5, obviously. 128, 256, 512, 1024, 2048. Let's just go at least all the way up to 2 to the 12th power, because that was our first comparison. So notice that I'm able to compare 5 to the 5th with 2 to the 12th. So let me go ahead and write down what they are so you can see better. Now, I'm able to compare these numbers. Obviously, there is a difference between them. But here's the most important part about this solution. Can they get closer than that? And the answer is yes. How can they get so close? Well, take a look at this. I got 125 and I got 128. Awesome. They couldn't be closer, right? That's awesome. So in other words, if you consider those powers, they're pretty close. I mean, don't you think? So I have 5 to the 3rd power, which is equal to 125, and I have 2 to the 7th power. Obviously, that's the 7th power if you calculate that. it's going to be 128. And I know that 5 to the third is less than 2 to the seventh. But guess what? They're pretty close. So that's kind of nice. Great. Now, here's the million-dollar question. How do you transition from this to our original expression, which was 5 to the power 51 and 2 to the power 120? And the answer is very simple. By raising both sides to an appropriate exponent, you're going to be able to get something like that, or at least you'll get close. While thinking about 51 being a multiple of 3, this is what I'm thinking. I'm going to be raising both sides to the power 17. And that's a legitimate operation, right? Since both sides are positive and 17 is an odd number, we're good. So what does this give you? Well, 3 times 17 is 51. That's why we raise both sides to the 17th power. Remember that? So this gives me 5 to the power 51. And the right-hand side is 17 times 7, which is 119. Oopsies, I did not get 120. But don't worry about it. We'll take care of that. And that part is actually also very simple. Now, I was able to get that 5 to the power 51 is less than 2 to the power 19. But in the original problem, remember that I am supposed to compare 5 to the 51 to 2 to the power 120, which is 2 times the right-hand side. So what is that supposed to mean? Well, I can safely say that 2 to the power 119 is less than 2 to the power 120 because 119 is less than 120, right? And 2 is greater than 1. So this is satisfied. Therefore, by using the transitive, what's that called? Okay, I couldn't say it. Transitive property of inequalities, I can safely say that 5 to the power 51 happens to be less than 2 to the power 120 because it's already less than 2 to the power 119, which is less than 2 to the power 120. So it's obviously less than 2 to the power 120. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.